In the given figure A, which is this vector A, is 15 meter per second square, total acceleration of the particle, radius is 2.5, and the speed of the particle is being asked. See, we know that if this is A net, right, total acceleration A net, and if this is 30 degree, we know that this vector is actually A cos 30, and this is A sin 30. So what is actually given in the question? It is given in the question that A cos 30 is equal to the, so this is A cos 30, right, and this is actually equal to the centripetal acceleration AC, which is nothing but V square by R. So what are we trying to find out? We're trying to find out speed of the particle, right? So what is V square is equal to? So V square will be equal to R into A cos 30. So what is the value of R? R is given to be 2.5. What's the value of A? Is given to 15, and cos 30 is root 3 by 2. Okay, now we have root under root, so let's do some manipulation and make the calculation look simple. So we can write this as 2.5. What I'll do is I'll write it as 25 by 10, right? 25 by 10 into 15 into root 3. See, root 3 is 1.7. So 1.7 by 2 is 0.8. 0.8 I can write it as 8 by 10. So this becomes into 8 by 10. So now what I'll do is 25, 15, 8. What should be easy way to calculate? So okay, let me write like this. 25 by 10 into 10 is 25 by 100. 25 by 100 into 15 into 8. 2500 is 4. 4 2s are 8. So what you get is 15 into 2 is 30. Which means V square is equal to 30. See, though this question is a really simple one, so it took me somewhere around 2 minutes to write it down. Of course, in the examination you don't need to write these many steps, but yet this is slightly time consuming. So if V square is 30, V is equal to root of 30. See, if 5 square is 25, 6 square is 36. So definitely root of 30 will be lying somewhere between 5 and 6. So that option which is between 5 and 6 is 5.7. Now please don't tell me 5. Why can't we take 5? Because 5 square is 25 and not 30. Okay. So the most appropriate answer would be 5.7. But then we have discussed this question, I think 2 to 3 times. Yet let us have a brief outlook again. So this is a particle executing circular motion in the clockwise direction. This is the velocity vector, right? This is the centripetal acceleration, and this also is the tangential acceleration, and we know that the resultant vector is A net, right? So now in the question it is given that for the same condition, what the question says is, it doesn't talk about velocity, it doesn't talk about centripetal acceleration either. What it says is the net acceleration is inclined at an angle 30 degree. So now if you resolve this 30 degree vector, what do you get? If you resolve A net into two components acting at an angle theta, this component would be A cos 30, and what would be this component? This component would be A sin 30, right? So okay, now if you have doubt in that resolution, let me clear that part also. So say if this is right angle triangle, right, starting from here, I can, right, so if this is 90 degree, and if this is 90 degree, and if this is theta, say if this is A and B and C, what is cos A is equal to? See, cos A will be equal to, what will be cos theta? Cos theta will be equal to B by hypotenuse, right, which is A. So what is B is equal to? B is equal to A cos theta. Now compare this diagram. Instead of A, we have here A net. So that we can written as A net is equal to, instead of instead of B, we here have, instead of A cos theta, we here have A cos 30. So that's how you get A net is equal to A cos 30, and the other way around. If you this goes really basics. I mean, this goes really deep into the basics, but that's okay. It is okay that at times the basics need to be cleared again. So if you for angle theta, if you write down sine theta, what is sine theta? Sine theta is opposite, which is C, by hypotenuse, which is A. So how can you write C is equal to A sine theta? Now, while comparing C here, you have the perpendicular vector C, which is marked here, right? This vector is perpendicular vector. So this is A sine theta, which is A net sine theta, which is theta is 30 here. So this is A sine 30. Okay. So, that was a brief explanation about the concept. Now, in the same series, we have discussed about uniform circular motion, accelerated circular motion, and retarded circular motion. Please make sure that those who are here for the first time, please make sure you go to these videos and analyze the relationship between theta, that is between velocity, angle between velocity and A net. That's really important to understand. Okay, having said so, moving on to the next question.